The following is an example of the constant difference algorithm. The way we're looking at subtraction is what is the difference between these two numbers. And the difference between these two numbers on the number line will stay the same if I bump both numbers up the number line by the same amount. So the strategy here will be conveniently add the same number or the same amount to both numbers, and it won't change the difference. So in order to take the 3 from 1 in the ones column, what I need to do is add 10 to both numbers. The way I'm going to do that is add 10 ones to the 631, making that 1 and 11, and add 110 to the 273, making the 7 and 8. Because I've changed both numbers by the same amount, I've given the same amount to both numbers, I don't change the difference. But now I can take 3 away from 11 with 8, and I move on to the next column. Here I'm going to treat the column that I'm in as ones when the reality is they're really tens. So I'm going to try to take 8 from 3, which I can't do, so I need to add 10 to both numbers. So again, the reality here is that I'm adding 100 to both numbers. So I'm giving the top number, 631, I'm giving that number 10 tens to make the 3 tens 13 tens. And I'm giving 100 the same amount to the bottom number. So the 2 becomes a 3. So instead of having 200, now I have 300. But now, because I've given the same amount to both numbers, I've kept the difference the same. I've kept the constant difference. But I can take 8 from 13, which is 5, and I can move on to the next column. So now 3 from 6, which I can do, is 3. And the difference between the two original numbers is the same as the difference between the numbers once I've added 10 and 100, and if need be more. So the difference between the two numbers is 358.